Uh, I am Bashuman. I'm the principal engineer for Transit Gateway. This is Thomas. He's the general manager for Transit Gateway. And we are here to talk about a few new features, but particularly about Transit Gateway Network Manager. And before we get into new features and stuff, I would like to thank you for the tremendous adoption we have seen around Transit Gateway over the last 1 year. We have you, the builders, to thank for it. So on behalf of AWS, thank you. For better or for worse, we live in a connected world. And your business is critically dependent on the network it's running on. Without a good network, nothing else matters. And if you have a great network running beneath your application, it amplifies everything you do. And with a great network comes great networking capabilities. So before I get into the features we want to talk about, I would like to talk about a few core networking features of AWS. One, our AWS Global Network. The second capability I want to talk about is Global Accelerator. And the third, AWS Transit Gateway. I would like to spend a few minutes trying to share how we feel internally, think and feel about our global network and our global footprint in general. At this time, there are about 22 regions, 4 more being announced, 69 AZs spread along those regions, 13 more have been announced, and add more than 200 edge POP locations into that mix. And there you have our global network. However, when we actually build out our global network, our philosophy of availability is deeply rooted in a philosophy of isolation. So when we build out a region, we build out these physically segregated availability zones, and we take a lot of pains to ensure that failure does not permeate between the availability zones. And whereas we are very, very particular that failure doesn't permeate across availability zones, we are absolutely obsessive about not permeating failure between regions. And due to that stance, the question comes out very often that does this philosophy of isolation mean that you are disconnected? Hell no. We have one of the biggest cloud-based global networks that connect all our regions together. There are multiple redundant fiber links between regions, multiple 100 GBE links which actually serve out traffic between our regions and our edge POP locations. And it was not a network we repurposed for AWS. We built it up ground up. So we realized the need for a global backbone, and we built it up ground up for the cloud. It's a network on which your traffic, customer traffic, is prioritized above everything else. And that is how we give you a much more consistent network experience on our backbone, as opposed to the public internet. The second capability that I want to talk about is Global Accelerator. The whole purpose of Global Accelerator is to provide you a more consistent networking experience when connecting to AWS using intelligent routing. Allow me to explain. It's quite a mouthful. So you've set up this great web application. You've slapped a load balancer on top of it. You have a bunch of EIPs fronting it. Fantastic. Now you're ready to serve out your web service to your customers, to your branch offices, to your on-premises network. And whereas you have this great elasticity and availability of the cloud built into your application, you still have an unmanaged and an unpredictable leg to your customer experience. And that's the public internet. With Global Accelerator, when you enable Global Accelerator on your web application, Instead of using the EIPs that you're used to, Global Accelerator will allocate a set of Anycast addresses for you. And these Anycast addresses are advertised around the globe using our CDN network. Now what happens is that when your branch office or your on-premises network, even an IoT device, wants to talk to this web application, it does not traverse the internet completely to enter the AWS region. It enters our global backbone via the closest edge pop location to your branch device, to your branch office, irrespective of where your branch is located. What we are essentially doing here, if you think about it better, we are bringing the AWS global backbone to your neighborhood. That is the power of Global Accelerator. The third capability I want to spend a few minutes on is AWS Transit Gateway. So last year, we introduced AWS Transit Gateway to you guys. AWS Transit Gateway gives you centralized routing control. It is your elastic, virtual layer 3 router in the cloud. It can switch traffic between thousands of VPNs, VPN connections, and Direct Connect gateways. And what Transit Gateway gave you was the ability to centralize your routing mesh in the cloud. And with routing domains, a feature of Transit Gateway, we gave you the capability to isolate, segregate, and even inspect your traffic that was passing through Transit Gateway. It was a great win for all of us in general. Having said all that, these are awesome capabilities. These are great capabilities. But our customers, as they should, want more. And in talking to our customers, we have realized that they want largely, which could be broken down into 3 large categories of things. One, they want private global networks. They want one single coherent layer 3 routing mesh which will connect any of their cloud networks in any of the part of the world to another. Secondly, once they have built out this in-cloud network, they want to optimally connect into this network from their branch offices, from their on-premise data centers, from their IoT devices. Wherever they might be, they want an optimal connection into this large in-cloud network. And having built this expansive network out, what they really want is an intuitive and easy way to visualize, manage, and monitor that network above everything else. Having said that, I think we are ready to dive into a new few things. So how do you build a global private network? Yesterday, we announced the general availability of Transit Gateway peering across regions. Now you can take 2 transit gateways in 2 regions and peer them together, and they will exchange traffic. I think they are available at this point of time in Oregon, Virginia, Ohio, Frankfurt, and Dublin. These are the regions you can peer your transit gateways at this point of time. The other regions we are rolling out as we speak. So how do you peer 2 transit gateways together? We have tried to keep it as simple as possible. A transit gateway interregion peering behaves and looks exactly like a transit gateway attachment that you all know. You log into any one of the regions in which you want to create the peering. You choose another transit gateway, another region. You add in the remote account ID for a layer of verification, and we will take care of the rest. We will run our global workflows, and we'll hook the 2 transit gateways up together. And once you have actually hooked the 2 up, you will see attachments in both the transit gateways pointing to each other. At this stage, again, very much like you're used to your transit gateway attachments, add static routes into them, and boom, you're ready to start exchanging traffic between them. And so what do you have once you've peered your transit gateways together? We actually have an in-cloud private global network for you. Every VPC in every region now can talk to the other region the way you would think it would, through a centralized set of route tables in every region and a full IP routing table and forwarding system. You could, as you are used to with Transit Gateway, you have routing domains at your disposal. So at this point of time, now you can isolate, segregate, and inspect traffic at a global scale across your personal private network that is truly global. That is how we think we can give you a global private network. We are super excited about this feature, and we really would love to see what you guys do with it. Then we come to the second part of it. How do you optimally connect your branch office into AWS? So, Site-to-Site VPN, I'm sure many of you have used it. Site-to-Site VPN is a fully managed IPsec connectivity solution we provide to our customers for your branch office to connect into AWS. It has availability built into it. We provision VPN headends in multiple AZs so that one of the tunnels always stays up, so on and so forth. Yesterday, we announced accelerated VPN on Site-to-Site VPN. And what we are saying here is, with the existing features of Site-to-Site VPN, we are fusing the power of global accelerator into it to give you a more consistent network experience for your IPsec connections. How do you create your accelerated VPN? Again, we have tried to stick to the philosophy of simplicity. All you have to do is, while you're creating a VPN connection, click a checkbox saying whether you want to accelerate it or not. The product remains exactly the same. The way you configured your CGWs remain the same. We, behind the scenes, will accelerate it for you. In a non-accelerated VPN, you get EIPs that terminate in a region. In an accelerated VPN, you get anycast headends for your VPN connection. Otherwise, it's pretty much the same. So, in a pre-accelerated world, that's a terrible term, but I could not think of another. In a pre-accelerated world, you had your branch offices connect into your VPN connection that terminated on a Transit Gateway. And in this particular picture, the IPsec traffic coming from your branch offices would traverse the internet to come and hit our VPN headends. And that, again, puts in a degree of unpredictability into your network performance. And despite your Transit Gateway being designed strongly and having the capacity to switch your traffic, you're still open to the inconsistencies of the public internet. With accelerated VPN, again, very much like the web application we talked of in the global accelerator, you have your IPsec traffic leaving your branch office and entering the AWS global network through its closest edge POP location, irrespective of where your branch office is located. It will find the closest AWS POP location to enter the AWS global network. And once it has entered the AWS global network, you get a more consistent network performance as you ride our backbone back into the region. Again, we think this is the way in which you optimally connect in your branch offices into AWS. Again, we would love to see what you guys do with it, the performance gains that you see out of it, and we are super excited about it. And then we finally come to, how do you simplify network management? How do you visualize, monitor your private global network? And for that, I'll invite Thomas, the star of the show, to speak on it. There you go, Thomas.
Thanks, Josh. I'm not sure if I'm the star of the show, but I will tell you guys I do not like public speaking, so I'll do my best to kind of get through this in a reasonable time. So So Bashman covered a lot of ground in the networking category, but there's still a critical piece missing. If you think about it, how do I manage it all? So I've been able to peer transit gateways across regions. I've been able to use accelerated VPN. I'm using transit gateways. I'm connecting a whole bunch of VPCs together. At the end of the day, how do I manage it as the network gets larger and larger? And so to address this problem, we launched AWS Transit Gateway Network Manager yesterday. And the idea here is that we wanted to provide a set of features to our customers to be able to simplify how they build and operate their global network. And if you kind of take a step back and you think about what Transit Gateway is, it's your virtual router in the cloud, right? It's your hub and the connection point between your VPCs, your VPN connections, your direct connects, and even now your peering connections across transit gateways. But you need some way to visualize your network, right? Right now you can build all that with APIs, but how do you visualize that? How do you manage it? How do you actually monitor it and see what's happening and going through your transit gateways? You'd have to build a whole bunch of different things on top of what you have today to be able to do that. And so we went to the drawing board and said, how do we provide that functionality to our customers? And with the launch of Network Manager, we're hoping to start that process off and get feedback from you guys as our customers. The other part is as you're building a global network, you also realize is that connecting branch offices to AWS can be difficult at times. And so we worked with a number of SD-WAN partners who are already managing branch devices. And what we've done is worked with them to integrate their solutions into what Network Manager. And what this allows customers to do is to automatically provision, configure, and connect their branch appliance to AWS seamlessly. And we'll go through some demos and illustrations of that as well too. But finally, the hard part is even if you build your network and you manage it and you connect your branch offices to it, the challenge is where's the network visibility? How do I know what's going through that connection? How do I know when events happen? And so what we wanted to do here is be able to provide our customers network visibility and metrics as well as events. So when things are happening in your network, you can then take action on those. And we'll go into more of that later. So this is the new Network Manager dashboard. And what you see here is the overview page. And in the overview page, in this example, I've got a network that consists of 5 transit gateways across 16 branch sites and 50 branch devices. And what you don't see here, and we'll go through it a little bit later, in this network that I built, there's 80 VPCs and 50 VPN connections and a direct connect. And I'll show you where that is in the network. So this is a fairly large network that's going through here. And in the middle section here, what you see is my 5 transit gateways that I've included. And you see VPN status. So what you're seeing here is the VPN down tunnels, the impaired tunnels, and the up tunnels. And so this gives you a quick snapshot of connectivity from transit gateways back to your branch network. So you can get a quick snapshot or overview of that. And in the section down below, what you're seeing is network events. And we'll go into more about what this is later. But what we wanted to do here was to summarize the types of changes that are happening in your network. And so some of the types of changes could be a topology change. So my network's changing because I'm adding a new attachment to a transit gateway. I added a VPC to my transit gateway. I removed a VPN connection from my transit gateway. Or I did a status change. My VPN tunnel went up or it went down. I want to be able to see those type of events happening and know, was that expected or not expected in the network? So you're probably wondering, how do I create this? How do I go through a process of creating a global network? And then what can Network Manager do that I can't do on my own today? And so let's go through that. So you start off by creating your global network. And so what you would end up doing is just go through your VPC console, select Network Manager from the left-hand menu under Transit Gateway. On the Create Global Network page, you'll just put in a name. And so in this example, I'm going to use my global network. I'll give it a description. And then add any tags or metadata that you think would be useful to help describe or include into your global network. And then, once it's successfully created, I can go to the dashboard overview page, and I can see the metadata that I just created. That's it. With a few calls and a few clicks in the console, I've created a global network. Almost. So what I actually created in this case was actually an empty container. So I just created a shell of a global network. I created sort of, here's what I want to represent. And you can have any number of global networks in your environment. What I need to do next is, how do I, from that shell, create and include all my AWS resources? How do I include my transit gateways, my VPNs, my VPCs, my direct connects, and even my peering connections? And how do I include my branch network and those devices and those sites in there? So let's go through that process. When I started earlier, I mentioned that we built Transit Gateway Network Manager on top of Transit Gateway. And if you think about it, Transit Gateway is that data plane, and this is the management layer. So what we're doing here is when you register transit gateways into your global network, what we're going to do is take all the different attachments that you have and then build a network graph off of that. And so as you add and remove attachments to your transit gateway, your network graph actually dynamically changes. So let's take a look at what that might look like. So I click on Register Transit Gateways. In this case, I have a list of transit gateways that I have access to based on my account permissions. I'm going to select 5 of them. I'm going to select 1 in Ireland, 2 in Northern Virginia, and 2 in Oregon. So 5 transit gateways. I register them, and now these 5 transit gateways are now part of my global network. That's it. Now, from there, what happens? Well, this is where it gets a little bit interesting. So in this page, instead of going back to the overview page, I thought it would be interesting to actually look at the network topology. So remember when I said Network Manager will build that network graph? So this is our hierarchical logical view of what that network graph would look like. It starts with the global network. It shows you the transit gateways that are attached. And then based on each of the attachment types, in this case you see VPCs, you'll see direct connects there, you'll see VPN connections. It'll fan out and actually show you what that logical network looks like in your global network. And also, it's not just a logical view and it's not just this hierarchical view of what your global network looks like. Remember earlier we saw the VPN status, we saw the down tunnels and the impaired tunnels and the up tunnels. We actually overlay that health information right onto the network graph as well too. So you get a picture of what your topology looks like as well as what is your connectivity look like to your branches. So let me give you a little bit more of what this looks like in a quick demo. Let's see here. So in this process, you can expand and collapse the different nodes of your topology, your network. And as you scroll through, you can see that it's basically breaking out based on each of the different attachment types across all the 5 transit gateways that I have. And I can click on a specific node of the transit gateway, in this case VPC, and I can launch from that VPC right into the VPC console. Going back to the topology page, I can look for that VPN connection that was impaired at the time, and I can go and look at what is that VPN connection. I can click on there, drive down to what resource ID that is, and then drive into the VPN console. So one of the cool features there is now I can use the network topology page to both give me a picture of what my network looks like, look at the resources that are there, and use it as a launch pad to jump to the Direct Connect console, the VPC console, the Transit Gateway console, or even the VPN console, right? All from one place, I can now start to drive to other areas of my network, okay? So before I move on, so I created my global network. I've registered my transit gateways. I've registered basically automatically, Network Manager registered all of my network resources from my transit gateway. But how do I then connect my branch sites? So when I connect my branch sites, I could do it manually, right? I could go in and create a branch site. I can put in the name, address, some latitude, longitude, and we'll talk about how we use that information later. So if you put an address, we'll go ahead and pick out the latitude, longitude for you, or if you know it, you can put it in there. I can manually create the actual branch devices that are there as well too. So I can put in manually the manufacturer, the model, the serial number, information about those devices. And there's actually a relationship. So I can actually model, here's the number of branch devices in my branch site. And if you think about it, a branch could be a simple office where I have only one device, or it could be a campus where I have multiple devices across multiple buildings, right? And so this allows us to now create a mapping of what your physical world looks like to AWS. And when Bashman talked about the connected world, this is how we're going to have to be able to connect these things together. Now, if you remember from my example, I had 50 devices, 16 sites, and if I manually sat here and created all these things, it would take a long time, and probably you guys would probably get pretty tired of that. So what we ended up doing was saying, how do we seamlessly make this an easier process for our customers? And we worked with 4 different SD-WAN partners to integrate into Network Manager. And so through that process, customers now can automatically provision, configure, and connect their branch appliances to transit gateways and integrate all this great information into Network Manager. So I'm excited to announce these 4 partners who've integrated their SD-WAN solutions into Network Manager. And please visit them at their booths. I know they'd be excited to share with you what they've done with Network Manager and their great solutions. We're currently working with other partners to integrate their solutions into Network Manager in 2020. And before we go to this next phase, I'm going to show you demonstrations actually from each of these partners. And the idea here is to really show the value of the partnership and the integration that these partners have brought to Network Manager. It's really about the combined solution. It's not just about what we do in AWS, but how we really build on that partner ecosystem and really deliver value to our joint customers. So let's just start off with the Cisco SD-WAN solution and how they've integrated into Network Manager. And hopefully we'll hear something soon. Can you guys hear it? Can you turn it up? Is it loud enough? I can't hear it, so can you turn it up? I'm being told that they can't hear it.
Automation workflow to create an IP.
They said keep raising it, so I keep getting, okay, I hear it's good now.
The branch and AWS Transit Gateway. In this workflow, we will use IAM roles to log into AWS account and fill the Transit Gateway information and hit submit. Branch to Transit Gateway connectivity is now in progress, and now once it's connected, vManage will also update TGW Network Manager with this information.
So this is great. So, we're excited to have Cisco SD-WAN solution integrated. And again, if you're a Cisco SD-WAN customer, please definitely reach out to them and talk about how they've integrated in. Let me show you a different example. So Silver Peak Unity Edge Connect also integrated. Let's go through what that integration looks like.
The AWS Transit Gateway Network API gives us the ability to use Orchestrator to subscribe to the AWS Transit Network and be able to configure network topology within AWS. We can associate appliances to the transit gateways to establish VPN connections on AWS. Then we can demonstrate the automation of the IPsec tunnels created by the Silver Peak Orchestrator to the transit gateways. And last, we enable dynamic routing using Border Gateway Protocol, or BGP.
Okay, great. So the first 2 SD-WAN partner integrations, which you saw is how they integrate and connect their branch devices to Transit Gateway and Network Manager. But they did actually a little bit more than that. They also integrated information about their branch sites, their branch devices, and let me show you some of the other information that they automatically were able to integrate. So this automated integration, in this case, there's 5 branch devices at this branch site. So I didn't actually have to manually create this. I could actually, this gets pulled in from their SD-WAN solution into Network Manager. And you see here in this example, there's 5 branch devices, and you see the location information. In this example, you're looking at Cisco ISRs, 1100s. You also can see, they can also load in the link information. So if you think about a connection from a branch, there's Transit Gateway on one side of it, you have a branch device on another, you need a transport. So either you're using, for example, an ISP like AT&T that's providing broadband connection through, or you're using like a secondary, like a Verizon LTE connection. In this example here, we can see what type of links they have from their branch site out to the internet. You also can see the mapping between their VPN connection from Transit Gateway to the branch device, and you can actually see the status of those connections. So in this case, we see that the links are up, they're using the primary links, and we see that both tunnels are up on each of the different branch devices. So some great information that's being connected across. There's a monitoring tab, we'll go into that a little bit later, but right here, automatically, without just a few clicks, from the partner SD-WAN solution, they're providing both connectivity, provisioning, management, and actually adding additional information about that branch connection. Now, I wanted to actually, with this partner implementation, or Aruba's implementation, what we're going to do here is this is going to be a little more interesting. They've actually taken it a little step further, and they've actually are leveraging 2 other features that Boschman talked about. They're actually leveraging both the inter-region peering and the accelerated VPN. So let's see how they did that.
We are excited to show how Aruba branches in different regions are connected to each other and access workloads in any region over the AWS Global Network. The Cloud Connect app on Aruba Central discovers the entire AWS Global Network along with all the transit gateways. Select any of the branch group, which could have thousands of Aruba devices, and connect to any transit gateway using a single click. You can also enable the accelerated VPN option to connect to AWS using the nearest edge location. Now you can see that the sites are connected to the transit gateways. If you go to the branches in New York and Sydney, you'll see that routes are exchanged through the AWS Global Backbone and they can talk to each other. Thank you.
So I don't know if you noticed it there. What they've done is they've taken for their branch devices, they've basically automated the connection into transit gateways. They've been able to send traffic from one branch to an AWS transit gateway, send that traffic across another transit gateway through the inter-region peering, and come out a different branch. Think about that. They've built a global network, and they also use the accelerated VPN to be able to optimize that traffic from the branch. That's the power of what we can do with our partners and their SD-WAN solutions. Now, Aviatrix is someone who generally isn't known for SD-WAN, but they just launched yesterday Cloud WAN. And Aviatrix was one of the first partners to integrate with Transit Gateway last year. And we're excited to see them back building on top of that foundation that they built last year. What Transit Gateway has been able to do for them is enable new features. And they're back here introducing Cloud WAN. So let's see what they're doing with Cloud WAN.
Introducing Aviatrix Cloud WAN. First, we register an existing Cisco iOS branch office router. We name it Aviatrix Branch, enter its IP address, and login credentials. We'll go ahead and add the optional address information as well, and register the router. Easy. Then, we select the registered router so we can attach it to AWS. First, select the WAN interface that will be used. Then select Attach to an AWS Transit Gateway. Select which transit gateway, enter a name, the AS number, and security domain, then select Enable Accelerated VPN and attach. We do a diff to see the updates Aviatrix injected automatically.
So I don't know if you notice here, what Aviatrix bring to the table with their Cloud WAN is something different. So if you're somebody who actually has Cisco iOS routers already deployed in your branch devices, what they're doing with their Aviatrix Cloud WAN is they're able to actually configure those existing iOS branch routers. What they're doing is automatically going in and configuring them. They're setting up the BGP settings. They're actually establishing the VPN connections and using accelerated VPN. And so now you have an ability with their Cloud WAN product to be able to actually configure and automatically configure and connect to Transit Gateway Network Manager. So you're probably wondering, why did I make you sit through 4 different partner demos, right? Was it so I could talk less because I really dislike public speaking? That wasn't actually the point. The point was to show that through the partnership with our SD-WAN partners, that we can bring together the best of both worlds. Through a single view and network manager, we can bring together the resources that are in AWS, Transit Gateway, VPCs, Direct Connects, VPNs, and we can bring that together with the on-premise devices at your branches and your sites. And you get one view of what that all looks like. And so notice how when I showed you the network topology view, that was that logical kind of view of how your network was put together. But what would that view look like if I actually plotted it on a map? So in Network Manager, there's actually a geographic view. And so the network, what we're talking about here is when you put all that information together, the transit gateways, the peerings, the VPN connections, the branches and the devices, now you get one picture of what that global network looks like. And in this example, I have 5 transit gateways that are peered together across 3 regions with 80 VPCs. I have 50 VPN connections, 1 direct connect, the 16 sites that we talked about earlier, and the 50 branch devices, all plotted here on your graph. So in one view, you can see a logical, in the topology view, you see a logical network graph. In this view, you see the physical view, and I can see here that in my California office, I have an impaired VPN connection. I might need to take a look at that. In my Minnesota view, I have a down VPN connection. That might be because I'm setting up a new branch and I expect it to be down. But here I can quickly look at, in a global view, what does that overall network look like. But here's where things get a little bit interesting, and this is why Bashwan started with the whole process of actually talking about our global footprint and accelerated VPN, and he talked about Transit Gateway and our new features that we put together. All of this is put together, and if you wanted to, and this is where it gets kind of interesting, if I basically logged into a terminal, I can actually do a ping from my Northern Virginia, branches and branches that are in my Northern Virginia, or even VPCs in my Northern Virginia region, and ping all the way to Ireland and get to any VPC or branches over there. I could do a ping from Oregon all the way to Northern Virginia as well too. So with the peering connections, I can basically connect all those things together. But I can do this. I can actually ping from Oregon all the way to Ireland through Northern Virginia. So I don't know about you, but in a matter of minutes, I was able to create a global network, register my AWS resources, build and connect my branch devices and connect those branch devices into my global network. And I was able to basically build and connect all that together in a matter of minutes using APIs. Now, if you think about that, traditionally it takes weeks to months to basically go and deploy lease lines. And we were able to do that in minutes. You're basically using the AWS backbone to extend your reach to your network across your branches in AWS. And this is what gets me excited every day, guys. When I come to work every day, I'm excited to work with talented people, and we work on these hard problems and figure out how to really deliver value to you, our customers. This is exciting stuff. So what else can I do on the map? So I can click on any node of the map. So I could click on, for example, the branch site here, the California office that had the impaired VPN connection, and I can take a look at it, and I see that here in this site I have 3 VPN connections. I see what transit gateway it goes to, and I also see the devices that it's connected to and what link it uses, and I can see which tunnel is down, and I could drive from there. Just like I did on the topology page, I can actually drive to the VPN console if I wanted to get more information there. I could click on the transit gateway. In this case, in the Northern Virginia region, I can click on the transit gateway. And because I have 2 transit gateways, there's a drop down there, and I can select which transit gateway I want to take a look at. And just in this example here, I can look at that I have actually 10 VPN connections there, and I see which of my VPN connections is down, with both tunnels down. And I can then go and manage that one as well too. But if you notice, we actually broke apart the attachments as well. So you can see here in the transit gateway, I actually see the VPC attachments. But if you take a closer look, you actually see we have bytes in, bytes out. We actually have black hole packets and no route packets. Now, if you're familiar with Transit Gateway, right now we integrate into CloudWatch metrics, but we integrate only at the aggregate level. So when you're looking at these metrics, you only see the aggregate traffic that's going through a Transit Gateway. What you're seeing here is we're actually giving per attachment level metrics. So now you can actually see what data is actually flowing through each of your attachments. This is coming out in January of 2020, so you're getting an advanced look. Nobody else has seen this yet, so you're getting an advanced look of what that looks like. And what can you do with that? So you can see what's going through your VPCs, but you can actually also see what's going through your peering connections. So if you have transit gateways that are peered across to different regions, now you can see what traffic is going across there. And just like we saw earlier with the VPN status information where you saw the tunnel status, you can also see the traffic that's going through your VPNs. And those VPN connections could be going back to your on-premise or your branch locations. So now you get to see better insight or more insight into the type of traffic and the volumes of traffic that goes through your network. Now, we talked about how do you create a global network. We talked about how you register all the network resources in your global network. And we talked about how you connect your branch devices to your global network. And while it's important that customers are able to build and manage and connect all these things together, there's still something that's equally important. And those of you who are network administrators and manage these type of large networks, you know that you need to be able to monitor your network, because a network isn't static. It changes, right? As soon as you connect everything together, things change, and you want to know what's happening. And so one of the areas where we wanted to provide visibility is how do we provide that visibility at cloud scale? And so what we did was we integrated Transit Gateway Network Manager with CloudWatch. And as you know, CloudWatch collects monitoring and operational data in forms of logs and metrics and events. And it provides you a unified view of AWS resources and services that run in AWS or on-premise. But if you take a step back and you think about this, is that what we're doing is we're actually using CloudWatch is our monitoring and event platform. And so when data flows through a transit gateway, we will emit metrics to CloudWatch as that data goes through each of the attachments. And as we emit that data, you basically can build a time series of that data so you can see historical trends. So was the volume kind of that attachment, was it normal? Did it go up? Did it go down? Was it expected or not? Did it happen to go overnight? You can start to see trends in CloudWatch and see what you can do with that. In this example here, in the monitoring page off the dashboard, what I'm looking at for my global network is I can look at the aggregate data that's going through each of my transit gateways. And so I can pick each one of them and take a look at it. In this example here, you see traffic going through, and then you see a drop because of a no route. So I must have had something where I didn't have an installed route, I dropped traffic, and then I realized that that was a problem, and I put the route back in, and now traffic's flowing through again, right? And this is what you could do at an aggregate level. This is what you could do today. Excuse me. But I can actually drive down, let me make sure I'm doing this right. I can actually drive down to a transit gateway itself. So I can look at a transit gateway and look at the aggregate transit gateway details, or I can drill down to an attachment level, and I can monitor and look at that historical trend over that transit gateway. So I can look at it into a VPC level, a VPN level, a Direct Connect level, a peering level. So I can start to see what's happening through my network. And we didn't have time to do this just because of the overall schedule, but there's actually a Transit Gateway tab, and you'll see that there's an overview page. In that overview page, I would have seen the number of VPCs, Direct Connects, VPNs, and Transit Gateway peerings that I would have had. And just like the topology page that we saw with at the global network level, that gets scaled down so I can actually look at the topology of just a specific transit gateway. So that same logical view of my network graph I can see at a transit gateway. We'll talk about events in a minute, and then monitoring here at the specific transit gateway. Let's see here. Okay. Now, remember earlier I was saying that that we can do some interesting things. So all that monitoring and metrics that we saw was at the AWS side. Because we can associate, when we have a VPN connection, we can associate the customer gateway or the CGW onto a branch device itself. And that branch device rolls up to a site. Now I can measure the traffic that's going through there. So in this example, that Washington office that has 5 branch devices, I can see the data in and data out that's going to that branch itself. And I can look at individual devices. So I can actually look at the other side of the network. I can actually measure what's happening on the other side of that VPN connection. Or I can drive into a specific device and see what the trend is happening on that specific device. Now, metrics is great, and it gives you that time series and that historical trend, and you can look at packets coming in and out and the packets that are being dropped, and you can see all that information. But we wanted to take the network visibility a step further. And if you really think about it, the challenge is that, have you ever wondered before, like, when did a particular route get installed in my network? When did a BGP session get established, or when did it go down? When did a tunnel go down? Or when did somebody decide to add a new VPC in there or new VPN connection? And that type of changes that are happening in your network isn't generally easy, even in a normal network on premise, and especially harder when you're distributed in the AWS cloud. And so we took that problem and we said, what can we do there? How can we improve that situation? And how can we help our customers? And so earlier I talked about how we integrated Network Manager with CloudWatch. Well, effectively what we're doing here is we're turning CloudWatch into an event bus. And so as changes happen to your network and that happen on a transit gateway, Network Manager will publish those events into CloudWatch events. And so things like topology changes, adding a VPC, removing a VPC, any type of attachments that happen to a transit gateway, we will publish an event into CloudWatch. A routing change, we'll publish those things into CloudWatch, or a status change, a VPN went up or down, we'll publish that in there. And so as those events happen, now you can do some interesting things with that. And if you're familiar with CloudWatch, you know that CloudWatch has the ability to fan out that information, right? So these events come in, what you can do is actually fan that out into logs, you can fan that out into SQS queues, you can fan it out to SNS, or you can even have Lambda functions. So you could actually have Lambda functions react to network changes that can then, you could take action on, right? So that if you think about it, the sooner you see the issue, the sooner you can react to the issue. And that's what we're hoping to do here. And so the first set of events, we'd love to hear back from you guys, what works and what doesn't work, and what other events that you would love to see in your network as somebody who has to manage and operate these networks. So here's what the event tab looks like. Now, I apologize for the big gray out in the middle, because it actually has the account details in there. And so what you see here is actually a real internal account. The account we're using that we actually put in here is the global account that actually monitors our global infrastructure for site-to-site VPN. So what we do with our monitoring system, it goes across every AWS region, it builds tunnels, destroys tunnels, there's short-lived, long-lived tunnels, and basically what we wanted to do is see what would it look like in Network Manager. And so we included that account in there, and what we ended up doing here was we wanted to see what happens to our global network. And so in this example, at 2311 UTC, you actually see a VPC attachment happening in the EU West 1 region. At 2307, you see a BGP session established in our AP Northeast region. So in a one-stop shop, you're actually able to see the different events that are happening in the network as they change. Now, that's great at a summary level, but what if I want more details on a specific event? So let's drill into one. So in this example, I can actually just expand that event and actually display the details in there. So that BGP session that was established at 2307 UTC, I see that it was established for my VPN to my transit gateway with an ASN of 65,000, and I actually get the VPN ID. It's that simple. I can get all this metadata of that actual event, and I can use that metadata to query on and drive for my analysis when I see an issue that's happening. And so that's pretty cool, and you can see that all in the console. But what if you want to do some more than what we prescribed as sort of the events? And that's where the power of CloudWatch comes in. So CloudWatch, actually, if you're familiar with CloudWatch, you can actually use CloudWatch Insights. So you can actually query all that data that we publish into CloudWatch. And so in this example here, what we're doing is to demonstrate the power of the Network Manager events. What we've done here is published basically all of our root installment events. So every time we install an event, we basically publish all that into CloudWatch. And in one query, we can actually query all the installments that are happening across the globe. And you can use that to understand when you're installing routes or withdrawing routes from your network. And you can see that. So those are time series, and that's information that you can pull yourself all on demand using CloudWatch Insights. And the idea here is with Network Manager is to really bring network visibility to that next level. And we're hoping that you will give us tremendous feedback about what other events you want to see. So we started the session by talking about our network capabilities and what customers want to do. And these things are all available actually yesterday. So they are actually available today, but the slide didn't update. So we know our customers want to build global private networks. And so with Transit Gateway inter-region peering, you're able to do that. You're able to connect data and connect your branches and your VPCs across one region to the next region using our private backbone. We know that customers want to optimize their traffic from the branch to the AWS regions. And so customers who are at branches or users at branches want to optimize the performance and hit the closest edge location so that they can get better latency and performance from their branches to AWS. That last mile gets reduced. You're not depending on your ISP for that last mile as much. And lastly, when we think about it, how do we bring this all together? Because as you grow your network, as you use more AWS resources, it gets harder and harder. As you connect regions together and add more VPCs together, how do we simplify that? And with AWS Network Manager, we're helping our customers try to build and operate their networks. And with the growing partnerships of SD-WAN partners, we're able to now connect automatically the branch network to the AWS network. So we're super excited about the adoption, as Bashman said, over the last year of Transit Gateway. And we really want Transit Gateway Network Manager in the hands of all of our customers. And so you're already paying for Transit Gateway, and so we're not charging you anything for Transit Gateway Network Manager. You could go today, take your Transit Gateways that you already have, create a global network, and then use the topology pages and everything I just showed you for free. I saw a clap or two, so I appreciate that. It's hard to tell with the headphones on. So, and then what's on our roadmap next? So we're going to continue to work with our partner, our SD-WAN partners, to onboard more SD-WAN partners onto Network Manager. Today, unfortunately, the Network Manager only supports single accounts. And if you're familiar with AWS's IAM roles and permissioning model, we have a strong permissioning model. And just because Transit Gateways were allowed to attach to different network resources and Network Manager was able to register Transit Gateways, we don't implicitly allow those connections to then connect, right? We have to explicitly do that. So we're working on multi-count support. That'll come in Q1 of 2020. Also, policy-based orchestration. The idea here is our customers are telling us that they want to be able to control what applications, what users can get to what applications, or what applications can go through which of your VPN links. And so we're going to be able to provide that ability for you to define the policies that say, I can get from point A to point B, or this application get from only be accessed from this VPC, or go through this VPN connection. And so that's what's coming next as a feature in 2020. And lastly, we know that customers aren't just connecting their branches to transit gateways and to their global network. We know that our customers also have users out there who want to connect into the global network. And so with AWS VPN Client, which we launched last year, we'll be connecting that or integrating that into Transit Gateway this year, or this coming year. And the ability for you as a owner or manager of your global network, you'll be able to see where those users are, how many users are using or connecting to your global network, the type of data that's flowing through there, and be able to manage that in Network Manager as well too. And for you guys, here are some additional networking sessions. These are very popular networking sessions, so if you want to drill down into more about Transit Gateway or Direct Connect or Private Link, they're great sessions, they fill up fast. Please go out and try to connect to some of these sessions. I know the speakers, and they do an excellent job of really diving deep into some of the details. And so I want to close with a thank you. I want to say that I'm really humbled, and thank you guys for being here. I've been sick for the last few weeks. Bashman and the team and I have spent a number of hours. You saw that we launched a lot of new things on Transit Gateway. And we're humbled by the fact that our customers have trusted us with their networks, and we want to continue to build and earn trust with our customers. And we're really excited about what you're going to do with the new features that we've launched. And finally, I'd ask that you complete the session survey in the mobile app. It helps us understand what we do well and what we're not doing well and what we can do to improve the situation or improve for the next time. Thank you all.